take different iterative algorithms and calculate the time complexity for them. In this algorithm, we'll ignore these assignment and output operations as they don't depend on n. We can ignore this loop also because it will always execute 6 times only, no matter what the size of input is. Even when n becomes 1 million, it will be executed 6 times only. This loop will be executed n minus 2 times, and this will execute n times. So time complexity is this, and it is of order n. Now let's take another algorithm. Here this loop will execute almost n by 4 times. So this algorithm is order of n. In this algorithm, this loop will execute almost n by 5 times. So this algorithm is also order of n. So we can say that the time complexity of loops in which the control variable is incremented or decremented by a constant amount is order of n. Now we'll consider loops in which the control variable is divided or multiplied by a constant in each iteration. Now here in this loop, this control variable I is divided by 2 in each iteration. If the value of n is 51, then this loop will have total 6 iterations. So the number of iterations of this loop is given by log base to n. We have seen that there is no need to specify the base of the logarithm in big O. So we can just say that this algorithm is of order log n. Now in this loop, control variable is multiplied by 2 in each iteration. If the value of n is 51, then this loop will also have 6 iterations. So number of iterations for this loop is also given by log base to n. So this algorithm is also of order log n. Instead of this 2, if we divide or multiply this control variable by any other constant, then also the complexity will be order of log n. So if in a loop the control variable is divided or multiplied by a constant amount, then the time complexity of that loop is order of log n. Now we'll consider nested loops. When we have nested loops, we'll be interested in knowing how many times the innermost loop iterates, because the iterations of innermost loop will always be more than those of outer loops. In this algorithm, the outer loop executes n times, and for each iteration of outer loop, this inner loop will execute n times. So the total number of times the inner loop executes is equal to n into n. The function t is equal to n plus n square, because this assignment executes n times and this comparison executes n square times. Now this n square is a faster growing term, so we can say that t is order of n square. Now in this algorithm, this outer loop iterates n times, and for each iteration of this outer loop, the first inner loop will iterate log n times and the second inner loop will iterate n times. So total number of iterations of this inner loop is n log n, and total number of iterations of this inner loop is n square. So this arithmetic operation executes n log n times and this comparison executes n square times. So the time complexity is this, which is order of n square. In this algorithm, this innermost loop executes n cube times and this inner loop executes 10 into n times. So time complexity is this, n cube plus 10 into n, which is order of n cube. Now we'll see some nested loops in which iterations of inner loop depend on the index of outer loop. So in these cases, we cannot find the total number of iterations of inner loop by just multiplying the iterations of inner loop and outer loop. Now in this algorithm, this outer loop executes total n times, and these are the number of iterations of inner loop in each iteration of outer loop. In first iteration of outer loop, the inner loop executes 1 time. In second iteration of outer loop, the inner loop executes 2 times, and so on. We can add all these to find the total number of iterations of inner loop. So total number of iterations of inner loop is this. So Tn is equal to this, which is order of n square. Now in this algorithm, this outer loop executes total n minus 1 times. And these are the number of iterations of inner loop in each iteration of outer loop. So total number of iterations of inner loop is this. Time complexity is this, and it is order of n square. We'll see this nested loop in selection sort algorithm. Now here, this outer loop executes total n minus 1 times. And these are the number of iterations of inner loop in each iteration of outer loop. So total number of iterations of inner loop is this. Time complexity is this, and it is order of n square. And we'll see this nested loop in bubble sort algorithm. Now in this algorithm, there is a function call in this loop. And this function is of order log n. So the time complexity is given by n log n. Now in this algorithm, we have an if-else statement. When this algorithm is executed, either this block of code will execute or this block will execute. While calculating time complexity, we generally consider the block whose order is larger. And in this case, this block is of order n square and this block is of order n. So we'll consider this whole if-else statement as order of n square. So time complexity is given by n log n plus n square, which is order of n square. Some algorithms perform the same number of operations every time they are called. These algorithms are said to take constant time and they are all of order 1. For example, this algorithm is order of 1 because it will always execute constant number of steps, whether the input size is 100 or 1 million. The number of steps does not depend on input size n. Some examples of constant time functions are a function that prints first element of an array of size n, a function that swaps first and last elements of an array of size n, or a function that returns the size of a stack.